Okay, if you've been forced to watch this, I'm going to have you check your work and write down the 5 words to show me that you listened. But here we go. This one, because of the marks, this one is going to be my start. This is where it's all starting. And these marks right here show me this is where it's ending. So make sure you know that. Here's one typical way, a double transformation. This should say really 2. But first one would be maybe to reflect over that y-axis. If I reflect that triangle over the y-axis, it ends up right here. So right there, reflect across the, nope, not the y, the x-axis. And then you can see from there, then it's going to be a rotation. Looks like I'm going against the hands of a clock. I'm going counterclockwise. Looks like I'm going about 90 degrees about the origin, the middle of that graph, to get to the final spot right there. So this final dot, when I rotate it, ends up, if that is, looks like it's a little bit off. Yep. All right. But I wanted this to be a rotation quarter turn to the left. I wanted this box to really end up. Well, it looks like that's correct. Looks like it's going right to here. This box is going to here. So that one looks pretty good. This box rotating, this whole box right here rotating to here. So that is legit. I got that right. So here we go. First step is to reflect across the x-axis and then rotate 90 degrees CCW counterclockwise around the origin, the middle of the graph. That's one way of doing it. Of course, you could have rotated first and then reflected across the y-axis. So no, there's more than one way of doing it, but that's just my first way right there, doing it in 2 steps. All right, moving on. Number 2. For this one, looking at these statements, both answers true, none of the answers are true, getting you to think, maybe more than one answer is correct. Don't just pick one. D is a midpoint of AC. Looks like that is the halfway point. That looks good. It looks like EB, this stretch, is bisected or cut in half of this stretch at that point D. So that looks pretty good. Both those statements looks good. So just make sure when you're doing that, don't jump the gun. When you see a good answer, more than one answer might apply. So be careful on that one. All right, so here we go. Next one. This one says all 3 corresponding sides. So that would be S, S, S. Anytime you have 3 sides the same, congruent for sure. At least one angle in each triangle is a right angle. So you're looking at, just angle there. But that's not enough. So that would be a no. All right, all 3 corresponding sides are in proportion. And again, proportion is similar. If I got a triangle and took it and copied it and then stretched it, they have the same proportions, but they're not the same in every way. They're not congruent, so that one's no good. Anything proportional, similar, but not congruent. Similar, same proportions. At least 2 pairs of corresponding angles are congruent. Angle, angle, again, not quite enough. And then a rigid motion carries. And again, I'll just try to show you. If I took this triangle and did one rigid motion, like one translate and just one motion in one slide, you can see that it should be able to cover up if you do that correctly. So it covers it up, which proves it's congruent in one slide. So I'm going to say a yes on that one. First word is red. Thanks for listening. All right, here we go. Number 4. This guy, looking at angle, side, angle, side, angle. A side sandwich between 2 angles would be true. side, side, side again. Anytime you see that, congruent. A rotation, and again, if I do a rotation, if I could try to show you here, if I do a rotation of this triangle from the middle, it should have one cover up the other in one rotation if I was to not stop. So again, to illustrate that, looking at that top triangle, as I rotate it, and one, looks like 180 rotation should cover up one triangle to the other. So that proves a rotation will get it done. And then this one says a translation. And again, that wouldn't be good because you're saying just moving one triangle to the other, it's not going to work. If I have this triangle right here and I'm trying to translate it in one move, I'm not going to be able to cover up the other one. So that one's no good on that guy. All right, moving on. For these, looking at these marks, when we practice one last time, know that this looks like some kind of weird anchor. This is the looking one that looks good, where you measure the angle and then you use that to actually measure. So again, we'll be practicing. That is the good looking one right there. All right, moving on. This one, a perpendicular, that's 90-degree angle, bisector chopping in half. Or this one looks like it's got all the marks, but this is not chopping it in half. These are angles. We're not talking about angle bisectors. We're talking about a piece, a line segment I'm slicing in half. All right, moving on. This one, this is your starting line. The one that has just all normal looking equation. This is your finish line, or where it's ending. So you can see if I graph that first one at -3, they always have the same parallel slope of -1/3 over 3 down 1. And I can see if it's starting there, it looks like this one is clearly moving up, shifting up. How many boxes? 1, 2, 3, 4, 5, 6, 7. Looks like K is 7. The shift up 7 to get the new line, starting way down there at -3, shifting up 7 boxes. Remember, that 7 doesn't give me the new line's equation. The new line's equation, of course, would be f of x with that same slope. But then that 7 combined, that -3 adding 7 gives me 1, 2, 3, 4, the resulting 4 y-intercept. So just be careful of that. Here we go, moving on. This guy, be careful. This wants only 2 points. I'm going to stress that a lot. So this is my starting line. Kind of looks weird. People don't really know what that is, but that's 1x plus 0 if you're really trying to see. So that means I'm starting at the origin, and then that 1 in front of x tells me right 1, up 1, right 1, up 1. That is my starting line. And then you can see all these dots, I'm going to be marked off if I do that. Let me talk about that in a second. And then it says shift up 2. So I'm going up 2 boxes on that to get my new line, which I'll do in red. And again, when you do this, you could only plot 2 points. So let me again try to show you that. That would be like maybe one big dot right here, and then maybe one right here. And then for the other line, there's 1 dot, there's another, nothing more. If you add another dot to it, they're gonna mark you wrong. If you try to do more than 2 dots, if you try to do 3 dots or 4 dots, they're gonna mark you wrong. So any 2 dots, I could show another couple dots like this if I wanted. I could have used this dot and then maybe one way up here, and then maybe do the same with the other one. Again, just 2 dots, no more than 2 dots for each line. All right, moving on. Next word is dawn. Dawn. All right, this one says form a square, so I need a reciprocal slope from either coming between T and Z, doing perpendicular to that line right there, or of course, if I look at the slope between K and T, I could do a perpendicular slope to that. So whatever you like to do, I'm going to start with just that bottom one, looking at between T and Z. If I drew a little line, that looks like I'm going over 1, 2, 3, 4, 5, up 1. So if I had a line slope between that stretch would be 1/5. If I opposite reciprocal that, that means I'm going to be flipping that and oppoing it. I need to come at this line Z at that pattern of right 1, down 5. Of course, if I go right 1, down 5, I end up down here, and that's not where I want my point. So I'm going to have to kind of oppo that. I'm going to have to go left 1, up 5 to get my fourth vertex here, which I could call A if I want. And then if I put those numbers in there, that would be right 2, up 4. Of course, if I came at it from this one's slope, this one looks like I'm going over 1, down 5. I could come at that slope reciprocal 1/5 through here. So 1, 2, 3, 4, 5, up 1 if I wanted to get A from that approach right there. But again, 2, 4. And then just realize on the exam, it's going to be a rectangle. It's not going to be a square. So 2 of these slopes are going to be a little different. So you could either come at it at this one at a reciprocal slope, or there's going to be a different slope because it's a rectangle. You could come at that rectangle. This one's perpendicular slope. So again, we're going to be looking at that, a rectangle, not so much a square. All right, moving on. Number 11, which one is perpendicular? Which has a opposite reciprocal? And you can see the only one that has opposite reciprocal is this guy right here. Opposite reciprocals. If I take 5 and I flip it over and opposite it, -1/5. All right, moving on. Which is perpendicular? I got 3/4. Well, I'm not going to make it. I'm going to take a little break right here. I'll be back in a second.